Okay, question 10. Sadly, we have modelling with logarithms. Does anybody actually like logarithms? I definitely don't. Sure, a student conducts an experiment and records the following data about two variables, x and y. The student is told the relationship between x and y can be modelled by an equation of the form y equals k b to the power of x. Our first mission here is to plot values of log 10 of y against x. So what we need to do, first of all, in this table is find the log of the y values. So it's log base 10. On your calculators, just use the log button. Hopefully you can get those values alright. So I've only gone to one decimal place here. If you look at the scale on the graph, it would be incredibly difficult to plot them more accurately anyway. So to one decimal place would be fine. Okay, so now we want to plot the values. So we use the x values across the bottom and our log 10 values up the side. And hopefully you can get something looking just like that. Okay, part B asks us to state with a reason which value of y is likely to have been recorded incorrectly. So, if we look at our points, most of them we can see sit on a straight line. So we do have a slight outlier here, which is the point when x is 4, so y is 1100. So we could say, I'm not going to write it, we could say the point for 1100 is an outlier. It doesn't fit on the straight line that the other points do. Anything along those lines and we'd be fine. Okay, now for the final part, by drawing an appropriate straight line, find the values of k and b. So, the appropriate straight line is the line of best fit between the points that we've just plotted. They don't sit perfectly on a straight line, but they are all pretty close to it. So we might all get slightly different answers here, because it would depend on our line. So, this line is of the form log y is equal to mx plus c. So, we know that the model is y equals k b to the power of x. So, first of all, we're going to manipulate the model into log y equals something on the right. So, first of all, take logs. So, log y is equal to log k b to the power of x. Now, by the laws of logarithms, we can split up the right-hand side to give us log b to the power x, add log k. And then again, by the laws of logs, log b to the x is x log b. So we got x log b, add a log k. So, if we compare this now to mx plus c, log b is the gradient and log k is the log y intercept. So now using our graph, we can find log b and log k, and then we can find b and k. Okay, first up then, let's do log k. So log k is the point where the line hits the log y axis. So it's this point here, although my line doesn't quite make it. So I'm going to say that's about 0.7. So we know then log k is roughly 0.7. Now this is saying log base 10 of k is 0.7. So k is equal to 10 to the 0.7, which I make to be 5. So there's the value of k. Now we need the value of b. Now to find the value of b, well, remember log b is the gradient of the line. So let's find the gradient. Okay, so to find the gradient with this type of question, I always use the 2 points furthest away from each other. So I'm using 1.1 and 6, 3.5. So gradient, remember, is log b here, again because log b is our gradient, it's difference in y, so 3.5 minus 1.1 over difference in x, so 6 minus 1. Now up on top, 3.5 minus 1.1 is 2.4 divided by 5, that gives us 0.48. So we know then log b is 0.48. That is saying 10 to the 4.8 is equal to b. So b is 10 to the 0.48, which to one decimal place I make to be just 3 actually. So there are my answers. B is 3, K is 5. Good times.